There is a water trough sitting at the back of my property. It is full. It has been full every morning this summer. No municipal connection, no pump running, no bill at the end of the month. The utility bill is a fixed cost only because no one has told you it does not have to be. These 11 systems, the same ones rural Japanese communities have used for over 200 years, are what fill it. The water came from the air, from the roof, and from the ground beneath the yard. And the system that fills it costs less than a bag of grass seed to build. Not one system. 11 of them, layered the way a watershed works, each one feeding the next, no single point of failure, no utility company in the picture. I am going to walk you through all 11 today. What they are, what they cost, and which one you can start this weekend. The first 4 cost between $0 and $12. One of them requires no rain, no humidity, and no electricity at all. I will get to that one in a few minutes. Now, the honest starting point. The atmosphere above your property right now holds more water than most people imagine. Roughly 12,900 cubic kilometers of water at any given moment. A well-known figure in climate science. What is useful is this. A standard 2,000 square foot roof in a region that receives 40 inches of rain annually can capture close to 49,000 gallons per year. That is arithmetic, not a forecast. 1 inch of rain falling on 1,000 square feet yields 620 gallons. The water is already coming. The only question is whether you catch it or let it run off into the street. Most homeowners have been told that independence from utility systems requires expensive infrastructure and specialized contractors. It does not. What it requires is knowing which systems match your property and in which order to build them. Now, before I go further, I want to say something plainly. These systems have real limits. If you live in a region with consistent humidity below 30%, the air-based collection systems, the first 2 on this list, will underperform. They work well in humid climates and coastal areas. They struggle in the desert Southwest. I would rather you trust me on this than build something that does not produce results in your specific conditions. 7 of the 11 systems bypass humidity entirely. Those 7 produce considerably more water. Week on this channel, one honest fix for your home and your yard, 30 years of methods tested by hand. Nothing sold to you. If that is useful to you, subscribe, and the next one will find you. System 1 is fog net collection. Fog nets are stretched mesh panels, typically 48 square meters in traditional Japanese mountain installations, angled perpendicular to the prevailing wind. Moisture-laden air passes through the mesh, condenses on the fibers, and drips into a collection trough below. A well-positioned fog net in a humid, foggy climate can collect a genuinely useful amount of water daily. Output varies a great deal by climate and net size. The materials, shade cloth mesh, and a simple wooden or bamboo frame, run between $8 and $12. You position the net on the windward side of the property, away from buildings that would block airflow, and collection happens without any moving parts, any electricity, or any attention from you. System 2 is dew harvesting panels. Smooth, angled surfaces left outdoors overnight collect condensation as air temperature drops below the dew point. The traditional Japanese version used flat stone surfaces tilted at a precise angle toward the ground. Modern versions use corrugated metal or polycarbonate sheeting. A dew harvesting surface can produce a meaningful amount of water overnight in the right conditions. Humid nights with a big temperature swing work best. The principle is the same one that makes a cold glass bead with moisture in a warm room. The surface chills overnight, the air releases its moisture onto it, and gravity brings the water down. System 3 is roof rainwater catchment. This is the simplest and highest yield system for most properties. The formula is fixed: 620 gallons per inch of rain per 1,000 square feet of roof surface. 2,000 square foot roof in a 40-inch rainfall region produces the equivalent of a serious water supply for a household's non-drinking needs across a year. The long-term material decision matters here. Metal or clay tile roofing lasts 60 to 70 years, and delivers cleaner collection than asphalt shingles, which shed petroleum compounds into the water and require replacement every 20 to 30 years. If you are re-roofing, the material choice is part of your water infrastructure plan. System 4 is the Downspout diversion and first flush filter. Open, uncovered tank loses noticeably more water to evaporation than a covered one. Covering your storage is worth the extra material cost. Sub-$15 diverter valve installed on your existing downspout redirects flow away from the foundation and into a covered storage tank. The first flush function discards the first few gallons of each rain event, which carry the dust, pollen, and debris off the roof surface, and then diverts clean water into storage. It is a valve and a covered tank. It is also the foundation that every other collection system feeds into. Tell me in the comments which of these systems fits your property right now: a spring you have been ignoring, a downspout that runs straight to the street, a roof that sheds thousands of gallons every season. I read every one. Now, the ground beneath the yard. Before you dig anything on this list, the trench, the swale, the spring box, call 811 or your local utility locate service first. It's free, and it's the only way to know where buried gas, electric, water, or communication lines run through your property. Do not skip this because the hole looks small. Some of the worst incidents happen from shallow digging, not deep excavation. System 5 is the subsurface condensation trench. This is the one that requires no rain, no above-ground humidity, and no electricity. Buried pipe, placed at sufficient depth below the frost line, sits in soil that holds a relatively stable temperature year-round. Warm summer air drawn into one end of the pipe by a slow passive draft cools as it travels underground, drops below its dew point, and releases condensation inside the pipe. That condensation drains into a collection point at the lower end. It functions continuously in summer regardless of what the weather above ground is doing. The buried pipe itself costs nothing if you are using salvage material. A basic installation runs under $20 in hardware. System 6 is the gravity-fed spring box. If your property has any slope with consistent seepage, wet spots, or a visible spring, that water can be capped, filtered, and channeled by gravity to wherever you need it, without any pumping. The spring box is a simple concrete or stone chamber built around the water source, sealed on 3 sides, and open at the back face where water enters. Pipe exits from the front, lower than the inlet, delivering water down slope. Cost, if the spring exists on your land, $0 in materials for the basic structure if you have stone or concrete block on hand. This is the oldest water system in Japanese rural construction. Rural communities across Japan ran gravity-fed spring lines to their homes for generations using nothing more than stone, gravity, and the knowledge of where water moves on a slope. System 7 is the sand and gravel biofilter. Traditional layered filtration used a similar sequence of substrates to purify collected rainwater and surface runoff before household use. The construction sequence runs coarse gravel at the base, medium gravel above it, clean builder's sand next, and a layer of biological mat material at the top where beneficial bacteria colonize and break down organic contaminants. Water enters from the top and exits from the bottom, clarified and biologically filtered. This is not drinking water treatment. For potable use, a second treatment stage is required. UV exposure or slow sand filtration are the 2 methods that work without chemicals. For irrigation, washing, livestock, and toilet systems, a sand and gravel biofilter handles the load reliably. System 8 is the Cistern network. Underground storage tanks, linked by gravity-fed pipes, accumulate water from multiple collection points across the property. Property with 2,000 square feet of roof surface, a fog net, and a dew panel feeding into a single covered underground cistern can build serious reserve across a wet season. Underground storage maintains consistent temperature, resists evaporation, and keeps algae from forming. System 9 is the swale and infiltration basin. A swale is a level trench cut on contour across a slope. It slows moving water, spreads it horizontally, and allows it to sink into the ground rather than run off. That recharges the soil and, over time, the water table beneath the property. The cost is the labor of digging, nothing more. Open water feature on this list, especially the Trough and the Swale basin, can attract mosquitoes if water sits without moving. A simple aerator, or a few mosquito dunks, sold at any garden center, keeps that in check without chemicals that would affect the rest of your system. System 10 is gray water recapture. Household water used for washing, bathing, and laundry can be legally and practically redirected in most jurisdictions to subsurface irrigation and toilet systems. Well-designed gray water loop can meaningfully extend a property's effective water supply. The exact percentage depends heavily on household size and habits. Gray water systems must never connect directly to your potable water lines without a proper backflow prevention device. Cross-contamination between gray water and drinking water is a real health risk, not a technicality. Check your local code before installing this. Some jurisdictions require a permit. And get the backflow device right even if nothing else about the system is fancy. System 11 is not a tool. It is the design relationship between all 10 systems above. I have thought about this property the same way for 30 years. My father, Hiroshi, thought about the hillside outside Nagano, where I grew up, the same way before me. He kept a hand-drawn map of every seep and wet spot on that slope, updated after every rainy season, and he would not let a single drop of runoff pass a spot on that map without asking where it should have gone instead. Surface is either collecting or losing. When you design the systems so each one feeds the next, you stop losing. The roof fills the cistern. The cistern overflows into the swale. The swale recharges the ground feeds the spring fills the trough, the gray water loop extends what the trough supplies. No utility connection, no single point of failure, no bill. That is the model Japanese rural communities ran for 2 centuries. Not 11 separate tricks. One integrated system that mirrors the way water actually moves through land. The water trough at the back of my property is filled by systems 1, 3, and 8 working together. The trough was full the morning I filmed this. It cost nothing to fill each day. Start with the roof and the downspout this weekend. Walk away from the utility bill, one system at a time. Those 2 alone change the number.